Hello, my name is Yahya Hassanzadeh. I have a PhD in computer science and engineering from Koç University, and I'm currently working as a senior distributed systems engineer at DapperLabs in Vancouver, Canada. My presentation title is a smart contract enabled LightChain test network, and the co-authors on this demo paper are Kedar Kshatriya from Savitribai, Phule, Pune University of India, and Professor Öznur Özkasap from Koç University in Istanbul, Turkey. In this demo paper, we enable running smart contracts on top of LightChain. LightChain is our previous work. It is a separate publication available here, and it is the first ever scalable DHT-based blockchain. The prominent features of LightChain compared to the existing well-known solutions are it improves the message complexity of the nodes to generate a new block from O(n) in traditional blockchains to O log n in LightChain, where n is the number of nodes in the system. Also, in a LightChain system with n nodes and b blocks, LightChain imposes a storage complexity of OB/n to each node, which is a remarkable improvement over the traditional OB storage complexity, the linear storage complexity in traditional blockchains. Also, LightChain is the first ever blockchain that eliminates the need to follow the ledger updates from nodes, and nodes can directly query the state of another node in the system without ever following the blockchain updates. LightChain also provides reaching consensus in O log n message complexity with fairness, security, and immutability guaranteed. And LightChain is one of the pioneer blockchains that is safe under the corrupted majority of the nodes. We have already provided a proof of concept implementation of LightChain in Java as a separate demo paper, and the implementation is available in this repository. However, this implementation doesn't support a smart contract-based transactions, although the original protocol of LightChain supports the smart contracts. So in this demo presentation, as our original contribution, we develop supporting smart contract-based transactions on top of this LightChain proof of concept test network. And the implementation of this demo paper is available in the same repository as the original implementation of LightChain. This figure shows the overview of software architecture in the smart contract enabled LightChain test network. As we show later, the entire test network is encapsulated in a Docker container, and upon a startup, it reads all of the contracts to be deployed from the contracts directory in the root of the project, as well as the simulation configuration. The test network then spins up as many as nodes as specified in the simulation configurations based on the parameters determined here. And then it plays the simulation scenario by orchestrating these nodes and collects their logs. The logs are shown in real time in Docker standard output, and also the logs are aggregated at the end of the simulation for later investigations in a .csv file. At the moment, all of the contracts should be written in Solidity, because the test network only supports Solidity-based smart contracts. This figure shows a very broad overview of the life cycle of a transaction in the smart contract enabled LightChain test network. In LightChain, in a LightChain system with n nodes, only O log n many nodes are involved in validating and reaching consensus over a transaction or block. Those nodes are called the validators of that transaction or block. And whenever a transaction owner submits its transaction to the network layer, the network layer finds its validators based on the validator assignment and contacts them, and those validators run the transaction locally on their EVM instance, Ethereum Virtual Machine. And based on the result of transaction execution, they may validate or reject the transaction. If they validate the transaction, then that transaction is made available as part of the next block on the storage layer of LightChain. And a storage layer is a decentralized layer, although it is stored on the validator's storage. Every node in the LightChain system can be aware of the next block and its constituent transactions. And once the next block is made finalized, the view layer of the validators is updated based on the state variables that the transaction changes or touches, in other words. And view layer is again a decentralized layer, so every node is able to query the view layer to find the block at a certain height, and also its set of comprising transactions. In what follows, our co-author Kedar is presenting a sample demo scenario of running a smart contract-based transactions on the LightChain test network. The demo scenario involves 5 instances of LightChain nodes. Each of them have a token state variable, and some of them are assigned as consumer, the rest as producer. And they are interacting with a sample marketplace contract by submitting transactions to the LightChain test network that invokes this marketplace contract. And upon invocation, the marketplace contract subtracts or adds the token value of the nodes based on their role in the system by a constant predefined parameter.
I will start the demo by discussing the new parameters that have been added to LightChain simulation config file. These are token, contract mode, and eCell. Token are the amount of assets that each node has at the start of simulation. Contract mode selects whether to start the simulation in the original LightChain mode or in the smart contract mode. And eCell are the specific amount that would be deducted from the node, and it has been added for our demo scenario. That is our demo smart contract. This smart contract represents a basic level marketplace where there are two types of node, producer and consumer. The amount that the producer has, that means the token amount, some amount will be deducted from the token if a node is a producer, and that would be passed to the consumer. This is our basic solidity file, and we can add multiple files or select different versions of different contracts with our this new functionality that has been added to LightChain. So let's start with our simulation here. What this command does, it creates a container, Docker container, compiling all those files. While doing this, whatever the .sol file is, it is automatically converted to a bin file which the EVM is able to interact with. This command starts a Docker container in background. We can see what are the different transactions that are occurring. As if a node is a consumer, it will take some electricity from the producer. So if a node is a consumer and we can see the transaction is true, so some value will be added to its existing token value. So the current token value, which was 19, from it a value is added of 10, so that's why its current updated balance is 29. And for the producer, the value has been deducted as he has transferred the amount to the consumer, and so its new updated value is 9. So from our simulation we can see this, and now to copy, to take out all the results and the information from Docker container, we use this command. What this command does is it creates a app folder which contains all the output log, as well as you can see this is the bin file that has been generated. Basically this is the bin, our smart contract is converted to this bin file. Here we can see all the logs, all the transaction validation, as well as the mine attempts that have been done by each node. These are the transaction logs. Thank you.